Looks like it might be a bad format. This is the robot wheel technology for the robo-scooter. In the scenario for the robo-scooter, we were trying, oh geez, I'm not having a very good here we're able to integrate the drive functionality, the suspension, and the braking into the wheel. But because the vehicle itself has a different kind of steering scenario, steering didn't need to be integrated into the robot wheel itself. Instead, the steering is done manually by the handlebars of the robo-scooter. And I think maybe it's probably good for me to wrap up because I don't seem to be having much luck with my videos. So overall, there are different robot wheel technologies that are already out there. A number of commercial companies are looking at solutions for integrated in-wheel hub technology. Some of these technologies would be the Michelin active wheel as well as the Siemens drive e-corner technology. There are also a number of electronic brake solutions that are coming out as well. You may have heard of the wedge brake technology, but one of the major problems that the electric vehicle industry is having right now for moving directly to a completely dry solution is that the brake technology is not ready yet. So particularly, we're seeing changes in brake technology within hybrid vehicles where you have a brake power distribution from regenerative braking as well as a mechanical brake solution. And eventually, everything will become regenerative and then electric mechanical solutions. The idea for being able to deal with some of the control electronics is that you need to be able to create a redundant system. And here we're looking at a TTP backbone. Most of the industry is actually moving to a FluxRay technology. But the idea is that within the data packet that provides information to one of the actuators or receives information from one of the sensors would be able to take a time base, and within that time base, segment out a number of smaller time bases where information can be transferred back and forth deterministically within that baud rate. So most of these redundant technologies or protocols are necessary for things like drive-by-wire steering as well as possibly drive-by-wire braking. The drive functionality is not a mission-critical scenario, so you can easily just use a traditional CAN bus interface to be able to send a signal. And this just kind of goes over some of the ideas that you might need to be able to have a feedback system into the wheel, because if you no longer have a mechanical connection between the wheel and the actual rack and pinion, you only have a cable, then at some point the user starts to lose its connection to the road, and so you need to be able to give a certain amount of feedback to the system, as well as create these redundant motor control and sensor technologies to be able to ensure that the user has a backup or a fail-safe opportunity. And similarly for the brakes, but for the brake technology, basically, since you have 4 actuators or 4 means for stopping the vehicle, the redundancy is not necessary on the individual actuator level, but rather is necessary more on the input level for your brake pedal or your driver interface, which might be a joystick or a paddle shift. So that's where the redundancy would be in the brake system. So in this scenario here, we're looking at the overall strategy for how we would be able to control our steering, braking, and drive functionality. And I think I'm going to go ahead and thank you guys for your time and apologize tremendously for the videos not being accessible. Thank you. And congratulations to all of the design winners from this week, as well as for the participation in this conference, and I appreciate the opportunity to be here. Thank you. Yep, looks good. Sorry. Are there any questions, or should I just full stop, right? I'm just wondering, because I don't know if I should take questions or not.
What do you need?
I don't need to take questions, right? Okay.
You finished?
I'm finished.
Ah, okay.
Yeah.